Okay, I'm not going to do the math way on every single one of these. What I'm going to do is just quickly go through this so that you have all of this as videos to start the homework with. The second one's a product rule. What if you have two functions that are multiplied to each other? And it wouldn't usually be polynomials, but you could get a kind of polynomial looking thing that's nasty looking. But usually it's that you get 3x squared times a special function like sine, cosine, or e to the x. I have e to the x here because e to the x you do see in medicine all the time. So I want to put in the e to the x as much as I can, and the logs I see all the time too. I should really use log base 10 because that's what you usually use. I'll try to do that. It's just that I'm really used to e to the x. So if you see another e to the x creep in, raise your hand and ask me when I'm going to put log base 10 in there, because that's what you guys usually use. It's just my mistake. So if I have two functions like this, the rule is first times the derivative of the second plus second times the derivative of the first. Product rule is pretty easy. So the first step is to identify which one's the first and which one's the second. 3x squared is the first, e to the x is the second. Someone in the 1020 section asked, well, could you get three things in the product? And I said, yeah, you can. You get like a messy function times a second messy function times a third messy function, but not in Calc A. We save that for Calc 1. So you're not in Calc 1, so you don't have to worry about it. I don't think anyone's going to ask you something that messy. But then what you would do is, in that case, you'd glom the first two together, and that would be your first, and then the second one would be the second, and then you would have a second product rule to do in the first when you take the derivative of the first. It's messy. It's bookkeeping, but it's messy. So then the next step is find the derivative of the first and the derivative of the second, and then plug them into the formula. First times the derivative of the second plus second times the derivative of the first. That's your derivative. E to the x is special because it's the only function you cannot get wrong, yet students still do. Don't get it wrong. It's the only one the derivative is itself. The derivative of e to the x is e to the x. And that's why it's special. My son was just asking me, he's learning this now in class, he's like, why does e get its own name? Like, because it's the only one where the slope is itself. And Euler found it, and his name started with the e, so it's named after him. That's where the e to the x is really important. If you have 2 to the x, you get a constant times 2 to the x. It's not exactly 2 to the x. E is the only one it works like that for. So you can't get this one wrong. So don't get this one wrong. If you hear that, don't get it wrong. E to the x is e to the x. Okay, so what if you had to find a tangent line? All of these will be hooked to tangent lines because that's the whole purpose. Otherwise, it's just a mindless procedure. So what if you actually had to find a tangent line at x equals 1, for example? Same old steps as before. You plug in x1 into the equation, you get y1 into the original function, you get the y1, then you take the derivative formula and you plug in x equals 1 into there. Whatever you get out, that's your slope. And notice I left the e's. E is actually a number, 2.717, something like that, right? It's like a number. Don't put out the number, just keep the e tacked on. I don't think we're going to do much more WebAssign, but if you had a problem like this in WebAssign, you'd plug e in there if it wants the exact answer. So 9e is something like 9 times 3, which is around 27. So that's an actual number. We just carry the e with us. So then you go y minus y1, which is minus 3, which was 3e, times m, which was 9e, times x minus x1. Same old, same old. You solve. And in the morning section, we did plot this on Mathway. Mathway has a little e symbol, and then we figured out you actually can type just e, and it works. It worked out, so there was no mistakes on this one. This is indeed the tangent line of this guy. Last one. This is one that my students in Calc 1 always have such a hard time with. And I'm convinced they have a hard time with this because they come into Calc 1 having taken calculus. And they memorize some weird thing from Calc 1 that they learned in high school, and they come in and I give them something that's slightly harder and they can't do the problem anymore. It's actually pretty simple. You just have to follow the steps very carefully. It's a bookkeeping nightmare. So it's when you have an outside function and an inside function, and that's not going to make any sense until I actually show you an example. But here's an example. You got square root of 5x squared plus x. What's the inside function? Everybody knows what I'm talking about. I saw lips moving. 5x squared plus x. It's right, the inside function. Okay, so that everybody knows what I'm talking about when I say inside function, even though I can't really define it other than a composition which is kind of abstract. So the derivative has a complicated form. It's the derivative of the outside function with the inside function plugged in for x times the derivative of the inside function. None of that makes sense until I actually run through an example. So I'm going to run through that. Step 1, find the inner function. You just did. It's 5x squared plus x. How do you find the outside function? You cover up the inside function with your thumb and put a big black X over your thumb. I didn't have a thumb, so I pretended to put the word thumb inside for the inside. I couldn't I thought of actually doing that, putting a picture of a thumb in there and then putting an X over it. But that cover up the thumb with an X, and that's your outside function, square root of X. That's how you find it. Simple as that. How do you change it so that you can use calculus on it? X to the 1/2 is the same thing as square root of X. That's that last law that you have in the laws of exponents. You want to do that because power rule. You want to take derivatives. It's easier when you know what n is. In this case, n is 1/2. Next step, your formula needs derivatives of insides and derivative of outsides, so find them. Derivative of the inside function is a little bit easier than the outsides, 10x plus 1, right? 5x squared plus x, 10x plus 1. Power rule. Derivative of the outer function, a little bit messier because you have fractions. 1/2 x to the 1/2 minus 1. In this case, n is 1/2. So you knock the power of 1/2 down by 1. That's minus 1/2 when you combine the fractions. And if you have problems with fractions, just like my 3rd grade teacher, just stop thinking about her, do it on the calculator. Don't make any mistakes. Just put it on, forget about it. You're not going to learn fractions now. It's too late. And you can still get a PhD. I'm proof. Fractions weren't that important. You know what? They don't like when you say that at parent-teacher conference. You say, I said something like that. Well, this is not going to matter at the end of the day, is it? Because I wasn't good at this either. They didn't like that. So you learn a lot of things here. Don't say something like that at parent-teacher conference. Okay, so I get 1/2 x to the minus 1/2 as the derivative of the outer, and then you plug everything into chain rule. Chain rule is the derivative of the outside function, but instead of x, you replace it with the inside function. So notice that I don't have my revolving PowerPoint where you see everything falling into place. So I left it blank there where the x should have gone, and instead of the x, you're going to plug in the inside function. So the inside function was 5x squared plus x. That gets replaced in where the x was. And then you multiply by the derivative of the outside function, which was 10x plus 1. Totally bookkeeping. You just plug everything in where it's supposed to go. Get all the right pieces and put all the pieces together. If people make mistakes on this, it's bookkeeping. And I just don't, it is, you saw me make a mistake, you kind of can find it on the way, but the more complicated the rule, the harder it is to find where the error was. So just a warning, do a few of these so you get practice at doing. I can just put up some on WebAssign that's not for grades so that you can practice some more and then the pressure's off. Tangent line problem's the same. I totally made this one up, but the numbers turned out nice. It must have been my day. Take x equals minus 1. I want to find the tangent line there. I find the y one first, which was 2. I get the m by plugging in minus 1 into the derivative. That gives me the m. I plug the m into the y minus y1. I got minus 9 something, minus 9/4 as my m once I plugged in the number. I did this all by hand without a calculator, which, surprising, I only got one wrong here. But you plug it into, this is like a machine now. All this stuff is like a machine. Y minus y1 equals m times x minus x1. The only difference is that you're finding the m in a different way. You're using formulas instead of using limits. So that's the only difference now. And then you plug in. And we did check this one also on Mathway this morning, and it worked out just fine. So I can post that for you because I recorded their class too. So I'm recording this too because we cleaned up the mistake. So are there any questions on this? Like I said, this is not confusing stuff. This is not like why are we doing this? This is procedural. So the only thing I can think of is if you have like an aversion to algebra, this is not going to make you feel comfortable. But on Wednesday's class, we'll work in groups so that you can work with people that do feel comfortable with the algebra, and then everybody can be at the same level. Just dig in, don't be afraid of an e or a square root. Just dig in and just be brave. Is that going to be on the website? This is I have my own things again. Like, I'd have to ask 15 questions on WebAssign to get the same impact. You don't want 15 questions, right? I got 6 here. I'll post them on WebAssign as optional, like if you want to do it extra and practice, just to see if you get right or wrong, so you can practice for the quiz. But I want you to know the rules, and I want you to be able to work with the special functions. So I posted here several ones with rules. The top is a quotient rule, the second is a product rule, the third is a chain rule, the fourth is a quotient rule again, and the fifth is a product rule, and the sixth one is a chain rule. But I put functions in there, instead of giving you a bunch of easy ones and then ramping it up to make them harder, I put all the functions as something important, all at once. So I don't have to ask you 15, I just have to ask you 6.
How can we get the extra credit?
Next week, well, I'll ask you another 3 questions on WebAssign that you can turn in early if you want to, right? I think we can learn quicker this way. Don't you?
Yeah, I like this way better, but
I
that's the only reason I would choose WebAssign.
The WebAssign, what irritates me is the selection of problems I have. They have some really stupid rote ones that anybody should get. And then they have some middle kind of ones, but only 2 or 3 of them. And then after that, they have these weird ones where every one of them you're going, what do they want from me? Because I get it, they want to ask you something interesting. Why can't I just ask you these questions all at once? I just want to do that. So next week I'll ask you maybe 3 questions off of WebAssign so that you can turn that early and get your extra credit. Good? And you can text me. Everybody's climbing. Everybody's grades are going up. I see it. So I'm really proud of that. And still not satisfied though. Everybody's grades have to rise until we got a whole class full of hundreds.
How about that?
It's going to happen.